The last step we're going to look at is the ideal gas law. So the ideal gas law is going to involve using moles, temperature, pressure, all of the other things. So for this one here, we're going to start with a sample that we're trying to find the volume. We're given moles, we're given temperature, and we're given pressure. So if we look at our equation for the ideal gas law, we have volume. We have moles, which is represented by N. So 5.03 moles is our volume. We don't know. Our temperature, T, is 28 degrees Celsius, and our pressure, P, is 0.998 atm. So if we look at what's given to us here, we have pretty much all of the variables. So the one that we're going to be looking for is we're solving for V, and we're going to solve for V not with either of these equations because we have the moles. So if you see moles with temperature and pressure, you see moles with temperature and volume, you know to use this one here. So we're going to use the one that we're solving for volume. V equals nRT over P. So our V equals nRT divided by P. So V equals nRT divided by P. V equals nRT divided by P. All right, to solve for this, we need to find the R. R is always the same. It's a constant. So this is going to be our R value for this. So when we're solving for it, we just need to plug in. Our V is going to be N, 5.03, times our R, which is 0.06201. So this should be, 1 here. And then we need to multiply by our temperature. So the temperature we need to have in Kelvin. So we're going to add 273 to the temperature to give us Kelvin. So if we do that, that'll put us at 301 Kelvin. We're going to divide this by our P value, so 0.998, and then we'll solve. So 5.03 divided by 0.06201. We're multiplying the top. So multiply the top and then divide by the bottom. So 5.03 times 0.06201 times 301 divided by our number on the bottom, divided by 0.998. So we're going to get a total of V equals 94.07 liters. And that would be our correct answer for this one. All right. For the next problem, we're going to use the ideal gas law again, but this time we're solving for pressure. So if we're looking for pressure, we want to find the one where P is by itself. So this is if we were solving for temperature, solving for volume, solving for moles, solving for pressure. So pressure is nRT over V. So our pressure is nRT over V. So let's look what they give us here. I'm going to say that this is moles again. So let's fill it in. We have our pressure, we don't know. Our moles, N, is going to be 23.3 moles. Our R is always the same. It's the same R we have here. Our T is going to be our temperature. So they give us this 25. So 25 degrees Celsius. We'll add 273. This will give us 298 Kelvin. So we were looking at this, RT over V. We just need the volume. So the volume is 212 liters. All right, to solve for this, we'll plug in. Our pressure is N, 23.3, times R, which is 0.06201, times our T, which is 298, all divided by our volume, which is 212. So for this one, our pressure is 23.3 times 0.021 times 298 divided by 212. So we should get a pressure of 2.03 atm. And that's the ideal gas law.